you suck at interviewing and you're not going to get any better. Oh, just kidding. Cracking the coding interview is one of the best resources for learning. I call it level 1 because it's a great start if it's been a while since you've taken a data structures class or slept through it the first time like I did. So go ahead and grab that in the link below. Oh, what's that? Also grab elements of programming interviews. It's a lot harder, but you'll be well prepared if you know it. Link in the description below. All right, so this question is a number of islands, and essentially given a grid, you need to find the number of islands on there. In our example, the islands will be represented by ones, and then water will be represented by zeros. So in this example I just made up, this would be an island, this would be an island, this would be an island, and this would be an island. And so anything that's connected from the top, bottom, left, or right, these are two islands because this diagonal connection does not count as one. So return the number of islands. Well, there's several approaches we could do to this. Really comes down to breadth first or depth first search. Doesn't really matter too much. You could run into which one you choose. Breadth first, I would say, makes a little more, could make more sense if you were worried about like Stack Overflow or something like that. Say you had a huge grid in memory and you didn't want to keep track of a ton of stack traces with depth first search. But since the depth first search implementation is a little cleaner, we're going to do that. So really, I mean, what are we doing at any one spot? So anytime we find a 1, we just kind of want to find that island. So in this very first case, looking at this 1, we would need to find everything in the island. So say we were able to find this, 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 and this, and then we need to mark it as visited. And so essentially, you can just drown these islands by marking them as water and move on to the next. So for every spot in this grid, we look for an island. If there is an island, we drown it, and then we add to the count. So pretty simple. Let's see how this looks like in code. So we're going to need our count. And then, what did we say? We're going to go through every single item, or every single grid item. So just a nested for loop. I always Y and Y. X plus plus. And then what are we going to do? So we only want to go ahead and search if it's a 1. So we'll start with that. And it looks like we're dealing with a 2D array of characters. So if grid at yx equals 1, then we'll go ahead and we know we've hit an island. So I guess we'll say search, and then I'll fill that in a sec. And then we also need to say we found an island. So what is our search function? So I'll call it depth first because that is what we're doing. We're going to need the grid, we're going to need an X, and we're going to need a Y to represent our current positions. So function header, private void depth first search, our grid, index, int y. So all this function needs to do is just drown the island, really. We don't have to keep track of anything. We just need to find every single one that this thing is touching and mark it as visited, essentially. So as with any recursive function, we need our base case. So we need to protect ourselves from, if x is less than, if x or y is out of bounds. So, or y is less than 0, or x is greater than grid at 0. Length minus 1, or y is greater than grid dot length. So in those cases, we'll just return. And then we drown this square of island. So we'll just mark it as 0. And then we need to drown the other surrounding islands. The potential surrounding islands. So we'll be doing search. We'll be saying, okay, grid, x plus 1, y. And then we also need to return the count at the end. Y plus plus. Stack Overflow error. Whew, that was what I was worried about with depth first search. Let's see here. X less than 0, y is. Well, here's what's happening. So we're not actually checking. So we're actually just keep looking at all the zeros. So even if it was just a 4x4 grid of zeros, we just keep on looking. There's no way of having, we're not marking them as drowned, or we are, but we're not checking that. So because we mark it here, we also need to check that the current spot we're going to is not 0. So, or if grid at y, x equals 0, then we want to get out of there. Let's run our code now. So we're happy so that works. So what's our runtime? We need to look at every square really. So it's O of n runtime, where n is the space in the grid. And then we're doing it in constant space because we're actually doing this in the grid. We don't have a separate grid marking, visited and stuff like that. So that was Leetcode number 200, number of islands. A follow-up that they might ask will be Leetcode number 694, which is the exact same question, but it's about distinct islands. And you might say, what's distinct? Two islands are the same if they have the same shape. And so these would be the same. Two islands would not be the same if they have the same shape but rotated. So this and this are not equal, even though you could get to this from I guess this would be a rotation and a reflection. But like this and this, these in this question right here, these are not the same. So how are we solving this? So very similar approach to before, but we need, as you may start thinking, we need a sorry, I'm just deleting some stuff. Okay, we do need a way to really store previous shapes, and then we need a way to compare them as well. There's two approaches. Let me write this example. In this case, there is one distinct island, right? But what could we do? So we could say, okay, to store a sub-island, why don't we just take the square that encompasses that. So for this, we would just say, okay, we'd have a starting x, starting y, an end x, and an end y, and then we would store the subgrid of the shape. And when comparing two islands, we would just say, okay, if the, why don't we just run through those two subgrids and check if all the values are the same? So you could do that, but that takes O of n extra space. So it would be a way to do it. It can get complicated once you say you get a very diagonal island. When that went like this, you would have to be wasteful and store the whole space of a bunch of zeros that you really don't care about. So that would be one way. Another way would be to, well, let's think, how are we exploring these islands? Well, there's breadth first search and depth first search, and which one of those could uniquely identify an island? Well, breadth first search, what is it? It's really a queue, and you add in all its neighbors, and you could, I guess, for breadth first search, you could keep the track of the item of the squares visited. But breadth first search isn't like inherent to it. It's like you're just kind of expanding from one point. There's no real direction. With depth first search, you go as right to as much as possible, and you go down as much as possible, and then left, and then up. So what I'll argue is that for any two shapes that are the same, not counting translation or rotation, they have the same depth first search backtracking order. What do I mean by that? So take this shape. Say we're starting at the very first one. I'm going to mark this with a start, actually. Well, if we had a depth first search function where we go, first right, then down, then left, then up. If we just stored the previous direction we went from, so when we say we went to the right first, okay, we would say, okay, there was a right in here. And then we would try to go right again, we would fail, there'd be nothing there. Then we'd go down, and we say, oh, we came down. And then we would go here, and we would actually end because there's no more spaces. At this point, you could actually check say we're storing shapes, we could check that this encoding, so, S, right, down, left, or some version of that. You can do whatever you want. You can use whatever symbols you want. You'd want to check if this was already contained. And if not, you're set. That's the whole idea. There is a reason why you need to actually mark the S here as a start as well, which I'll get to, but let's see how that looks like in code. We're going to do a very similar structure to the last one. So we're going to have that for loop, that nested for loop. And I'm lazy. I'm going to copy this over. Yes. And then we're actually working with ints, so we'll be comparing it to 1. Okay, so what are we going to work with? Well, let's just write out again the basics of our depth first search. So again, I'm going to copy it. This will be 0. So this is the same depth first search. We're not keeping track of the encoding though. So how do we do that? Well, first of all, we need really a set of our previous encodings. I'm going to call that encoded islands. Noting that for sets, you can't contain duplicates. So if we have two of the same encoding, then and we try and add it, it won't increase the count. So that's good. I'm also going to have a string of our current encoding. And I'm keeping it up here because we're going to be referencing it down here, and I don't want to pass it in through a function header. It's just a little cleaner this way. So we're going through. If we do find a spot that is an island, okay, what are we doing? Well, we do need to start the encoding. We'll say, okay, this is what it is. It's a new string. And in our depth first search, we kind of need to store. Remember when I was talking about how do we actually store this? Well, instead of looking here and saying, okay, as we go to this one, or I guess this is the same. Okay, so as you're looking here and we say, okay, we want to go right, you don't actually, we're not checking to see if this right one is an island yet. We have to add the right direction into the function call so we know that we turned right. What do I mean by this? Okay, so in this function header right here, we should have our string direction. And this represents the string, or the direction that we just came from. Oh, that doesn't work. I was gonna, I'll just say dir means the direction we just came from. Okay, so I'm gonna have a start. Start will not be just an S for start. That won't be used by anything. Let's see here. So after we do a depth first search, this encoding variable we're hoping will be filled out with a path. If not, it means we didn't hit an island. Actually, it will be filled out with something, no matter what. So I'll just say encoded islands dot add encoding. Won't add duplicate encodings. So now we have to fix this function because this one looks pretty good right now. I guess we have to return our this size at the end. So in our depth first search, now we have to keep track of a couple more things. So this looks like it's going to be the same, so that's good. We're still going to drown the islands, you know, marking it as visited. But how do these change? So we are going to visit in this order, but we also need to keep track of the direction we came from. So if we're going to the right, we'll just add an R. And if we're going to left, an L. And if we're going down, this isn't up because remember 0, 0 is the upper left. We're going to be going down. And then we're not actually modifying this encoding variable. So after we drown it, plus equals dir. That's the previous direction we went in. So let's walk through what's going to happen in this example. So just think of a this 4x4 grid. What's going to happen? So in our very first, at 0, 0, we're going to find that the encoding's nothing, but we are going to go into this loop. Our encoding so far is just an S as our direction. We pass this, we drown it, and then we go to the right. So in that next stack frame, we drown this one, we add right to it. We recurse again, we try to go right, that doesn't work. We try to go left, that's already marked as a 0. We try and go down, and we add D to it. Eventually we add a left to it, because we came from the left. And at the very end, we won't have any more any more spaces. We've drowned the entire island, so we eventually exit this, and we add in start, right, down, left to it. And we add that in. Hopefully this happens again at any other identically non-distinct islands. And we just return the number of islands. Grid x, y. Oh yeah, we're dealing with an int. Run. So looks like it passes that. Looks like it doesn't quite like that. It's missing an island. Okay, so I will try and explain this. So if you don't add this S for a start and this E for an end, I think that different islands can look the same. And I'm trying to think of an example right now. So this island right here will look like that. If you didn't have this ending thing, you could have a start. Well, for example, if you didn't have this, if you didn't mark the start, a right down left would look the same as this right down left because we're not accounting for that. What I'm saying is we need to mark this S as a start in our traversal. And I'm guessing that you need to mark the end somehow. These also kind of function as like, if we get every direction right, we mark the start, and then the end is kind of a, we did traverse every direction. That would appear to be the only way to get a unique encoding for every single island. So what's the runtime of this? It's actually the same as before. We still have to visit pretty much every single item in the grid, potentially. In terms of space, also we actually have to potentially store every single island in the grid. So that's, ov(n) runtime, ov(n) space, where n is the size of the grid. So yeah, and then your interviewer, if you're getting this in an interview, this is probably the follow-up question, but you might get an even more annoying one, which on the screen is number of distinct islands. So it's the same question as distinct islands, but what makes an island distinct now is they can basically islands that are rotated or reflected are the same. The code's very similar to distinct islands, but you have to rotate and reflect in every single direction. So that one's really long, and this video is getting long enough, so I won't do it. But if you'd like to do that, it's Leetcode number 711. So yeah, that's the islands and distinct islands counting question.